Hello everyone, I'm Lieutenant Junior, a Brazilian Air Force fighter pilot, and I'm here to talk about the allocation of SABER M-60 radar units in anti-aircraft defense operations. This work was carried out in conjunction with Professor Mauri and Lieutenant Possamai, both from ITA. The presentation will follow this script. So, Brazil has a network of radars throughout the territory that make up the Brazilian airspace control system. In order to complement the system, the Brazilian Air Force acquired the SABER M-60, which is a modular radar designed to integrate a low-altitude anti-aircraft defense system. The main question that this work tried to answer was, what is the most efficient way to allocate the SABER M-60 considering its purpose of use? In order to guide the study, the following objective was defined: to propose a method for the allocation of the SABER M-60 radar units based on a maximum coverage location problem, the MCLP. The allocation of a radar requires the consideration of several conditions such as number of available radars, threats to be faced, probable routes of attack, 360 coverage, overlay, and position of the anti-aircraft weapons. As for the definition of the MCLP, it was established by Church and Revell in 1974, based on the existing concepts of the coverage problems. In this optimization problem, we seek to maximize the population served within a distance or time of service in relation to an existing demand and having a limited number of resources for this. In this work, it was used the heuristic approach to solve the covering location problem. So the greedy adding algorithms with none, one, and two substitutions were chosen in order to achieve the objective. Starting the description of the method, first the points to be protected were selected, then the weights of importance of each point, each sector of the point, and each altitude were defined. Next, in possession of the threat capacities and your own anti-aircraft weapons parameters, we are able to determine the minimum detection distance and the desirable detection distance. The area formed between these two perimeters is the threat detection zone, a region equivalent to the entire set I of the mathematical formulation, and where the radar coverage should be maximized by the MCLP. With the radar and simulation parameters set, we are able to fill the coverage binary matrix. At this point, some tests are carried out to check if a point in the detection zone is within the coverage volume of a radar candidate position. If all requirements are met, that element of the binary matrix will be assigned a value of 1, otherwise a value of 0. This figure represents out of scale the view of a side section of the radar coverage, indicating the value that the points receive in the coverage matrix according to their position. After all those steps, the problem can be solved using the greedy algorithms, and the obtained results can be compared. They can be presented in two ways: textually, with the percentage of demand met, and graphically, with 2 and 3D plots of the results. The algorithm with one substitution was in general the one with the best performance, followed by the algorithm with 2 substitutions, and lastly by the algorithm with no substitution. However, there were situations in which the allocation with the highest percentage of coverage was obtained by the algorithm with 2 substitutions, or even by the algorithm with none. The times that each method took to solve the problem were also compared. As might be expected, the more complex algorithms took longer to complete. The general objective was achieved as it was found possible to structure and solve the problem as proposed. Despite the impossibility of guaranteeing the optimality of the choice, the results obtained should not be underestimated. Some researchers, as referenced on the poster, demonstrate that heuristic methods are capable of producing optimal or near-optimal solutions. Finally, this methodology complements previous researches and studies concerning the positioning of anti-aircraft defense assets. These were the main references used for this work. Thank you very much for your attention. I'm at your disposal for any considerations via this email. Have a great day.